Okay, this lesson is going to talk about the introduction to probability. So really just simple probability. So probability is a measure of expectation that an event will occur. Probability has to be between the values of 0 and 1, guys. The possibility of something occurring will never be higher than 100%. 100% is say, okay, this is going to happen. So it can never be over 100%. So there is a possibility of it being a 0% chance. And then, of course, there is 1, which would be 100%, and 0 would be 0%. In the middle would be 1/2, which you guys know to be 50%. And everywhere in between are all your other percentages or probabilities in the middle. But it has to be between 0 and 100. So, theoretical probability is the number of favorable outcomes divided by the total number of possible outcomes. So this right here is how you find the probability of whatever event it is that you're trying to find. So, your example, it says, you roll a 6-sided die whose sides are numbered 1 through 6. Find the probability of rolling A, a 4, B, an odd number, or C, a number less than 7. So first, let's do the probability of a 4. So let me zoom in here. So what would be the probability of rolling a 4? Probability of rolling an odd number, and the probability of rolling a number less than 7. If you guys want to write less than, you can. So, if you have a dice, most of you guys, I'm assuming, have seen or used the dice before. So how many 4s are there on a dice? There's only 1. So the probability of rolling a 4 would be 1 in 6 chances. The favorable outcome is a 4, which there's 1 of. The total number of possible outcomes, there's 6 different possible outcomes you could have. So 1 over 6, or 17%. Either way is fine. So what about rolling an odd number? Well, you have numbers 1 through 6. 2, 4, and 6 are even. 1, 3, and 5 are odd. So probability of rolling one odd would be 3 out of 6, or 1/2, which is 50% chance. And then probability of rolling a number less than 7. Okay, so we have 1 through 6. So that would be 6 favorable outcomes, 6 possible times you could get a number less than 7. So 6 out of 6 would give you 100% probability that that would occur. 100% chance that you're going to get a number less than 7. Okay, so number 2 then, it says you put a CD that has 8 songs in your CD player. You set the player to play the songs at random. The player plays all 8 songs without repeating any of them. What is the probability that the songs are played in the same order that they are listed on the CD? So, our favorable outcomes would be all 8 songs in the order in which they were put on the CD. So we want to find the probability that they are in the same order as on the CD. Most of you guys may not even own CDs anymore, but that's what we're trying to find the probability of. So there's only one way, guys, that we can do this. So the number of favorable outcomes is going to be 1. But this is going to be over top of the entire amount of possible ways there are to play these songs on this CD. So that's going to be a lot of possibilities. So we have to go back to what we talked about yesterday with permutations. If we have 8 songs and we can pick all 8 of them to put or to play in any type of order, what would 8 pick 8 be? Well, it would be 40,320. So it's actually 1 over 8p8, which is going to give you 1 over 40,320. Which is a large number. So 1 divided by 40,320 as a percent is going to give you less than 1%. So I'm not going to write that. It's going to be 0.002%. So leaving it as a fraction is fine. 1 in 40,320 chances of you playing those 8 songs in the same order that they have it on the CD. Okay, so now we're going to take a look at experimental probability. So theoretical probability was looking at something we know how many we had of what was happening, and we based our probability off of what we knew was already there. So now experimental probability is probability that is based upon an experiment that you actually did. So it's not like a dice where you just know you have 6 numbers on it. This has to do with asking people or conducting an experiment to collect data. So the probability of an event occurring for experimental probability is going to be the number of times the event occurs divided by the total number of trials that were gone through. So in your example, it says to help choose a mascot for a new school, 200 total students were asked to pick their favorite from the following mascots: a falcon, a lion, or a panther. So the results are shown in the table at the right. It says find the experimental probability that a randomly chosen student prefers the lion as the mascot. So we want to say, okay, what is the probability that a student prefers or likes the lion the best? Okay, so what's the number of times that someone said they liked a lion? How many times did that occur out of the total number of trials? So it looks like 76 people out of the total people asked, it was 76 that preferred a lion. So 76 over 200, if you simplify this, it would be 19 over 50. Which would be about 38% chance that someone would pick a lion as their favorite over the falcon or the panther. Okay, I'm going to do one more example with you guys, and then you're going to try the rest. So let's look at number 3. So it says each letter in English is written on a separate piece of paper and put into a bag. You randomly choose all 7 letters one at a time and do not replace them. So find the probability of each event. What is the probability that the first letter you choose is a vowel? Okay, if all of these letters were in the bag, and let's see, we have 1, 2, 3, 4, 5, 6. We have 7 letters in the word English. How many of them are vowels? So 2 of them are vowels. We have an E and an I, so it's going to be 2 out of 7, which if you divide that, you get a percentage of 0.29, which is 29%. So then what about the first letter chosen is an H? Well, how many H's are there? There's only 1. So that would be 1 in 7 chances, which 1 divided by 7 gives you 0.14, so 14%. So that's it. So theoretical and experimental probability. Theoretical is based off something we already knew, and experimental is based off an experiment you did and you're looking at the results.